Kinetic energy of a body rolling on a horizontal plane. Kinetic energy of a body rolling on a horizontal plane. Okay. When a solid spherical ball rolls on a table, a point on its surface rotates about an axis passing through its center and perpendicular to its plane of rotation. The ball also moves forward. It therefore possesses both angular velocity and linear velocity, due to which it has rotational kinetic energy and translational kinetic energy. Energy due to linear motion. Energy due to linear motion. Energy due to linear motion. 1/2 capital M B square. This is the equation number first. Okay. Where capital M is the mass of the spherical ball and small b is the linear velocity. Small b is the linear velocity. Linear velocity and omega is the angular or translational velocity. Okay. Angular velocity. Okay. Then energy due to rotation. Energy due to rotation equal to 1/2 I omega square. This is equation number second, where I is the moment of inertia and the spherical ball and omega is the angular velocity. Total energy E equal to 1/2 mb square plus 1/2 I omega square. That is 1/2 mb square plus 1/2 mk square omega square. That is 1/2 mb square plus 1/2 mk square b square upon r square. That is equation number third. First, special cases. First, for a spherical ball. First, for a spherical ball of radius capital R. Okay. I equal to 2/5 mr square and I equal to mk square. That is 2/5 capital mr square or k square equal to 2/5 r square. Okay. I equal to 2/5 mr square and I equal to mk square. That is k square equal to 2/5 r square. Then k square upon capital R square equal to 2/5. Okay. Substituting in equation third, we have E equal to 1/2 capital MB square in bracket 2/5 plus 1. 2/5 plus 1. Okay. 2/5 plus 1. That is 7/10 capital MB square. 7/10 capital MB square. E equal to 7/10 10 capital M V square. Second position. For a circular disc of radius capital R. For a circular disc of radius capital R, then I equal to mr square upon 2 equal to mk square, r k square equal to r square upon 2, that is small k square upon r square equal to 1 upon 2. Substituting in equation third, substituting in equation third, we get E equal to 1 upon 2 capital MV square 1 upon 2 plus 1, that is 3 upon 4 MV square, okay? Complete. Next is acceleration of a body rolling down on an inclined plane. In ionic solids, the coordination